What's up, everyone? Today we are going to learn about oxidation numbers. So we're going to start a new unit by looking at some numbers. So oxidation numbers are positive or negative numbers assigned to an atom according to a set of rules. It's going to help us with the redox reactions, which we'll learn about later. So how do we assign oxidation numbers? Luckily, it's usually just the ionic charge. So remember, everything in group 1 is usually +1. Everything in group 2 is usually +2. Then we move on to aluminum, which is +3. And then nitrogen is -3, oxygen is usually -2, and the halogens are -1. So a couple rules. Any pure element by itself is assigned an oxidation number of 0. We said group 1 is +1, group 2 is +2. Fluorine is usually -1, as are most halogens. Hydrogen's interesting. It can be +1 when combined with nonmetals, or -1 when combined with metals. Oxygen is usually -2. We're going to see a lot of oxygen in this unit. The sum of oxidation numbers is equal to the net charge on the species. So we'll practice that. But basically, if you have something like NaCl, right, this is going to be +1, and chlorine is -1. So the overall charge is 0. Okay, so first thing, elements have oxidation number of 0. So if you see an element by itself, even if there are 2 of them, the oxidation number is simply 0. Let's try a few different ones. So for each one, you want to list the oxidation number of each species or each chemical. So I'll help you out. Sodium is going to be +1. Chlorine, we know, has a -1 charge. Okay, potassium and oxygen. So if we look at our rules, oxygen is usually -2, and each potassium, because it's in group 1, is +1. You can always check the math, right? +1 + 1 - 2 is equal to 0, and so for any neutral compound, it should equal 0. H2O. So again, oxygen is -2, which means this hydrogen is going to be kind of like the potassium. It's going to be +1 in this case. Remember, hydrogen is +1 when combined with nonmetals. Okay, so let's try this one. I'm going to just get rid of that and show you how to do this. So CaSO4, we've got 3 elements here. I know that calcium is +2. It's going to be +2. Oxygen is usually -2, but we don't know sulfur. So we can actually use algebra to figure this out. Remember, any neutral compound should total 0. So how do we use algebra to figure this out? Well, we know 0 is going to be equal to calcium is +2 plus sulfur. We don't know what sulfur is. Plus 4 times -2. Okay. So if we simplify this, 0 is equal to -6 plus sulfur. So that means sulfur has a +6. Okay. So again, I just used algebra to figure out some of the more complicated ones here, where you can use the rules to figure out 2 of them, but you may need to use algebra to figure out the 3rd one. So here, the most correct answer is all of this. All right, hopefully you're starting to get it. I'll do a few more with you. So for HiO4, we want to write the oxidation number for each element. So let's try another one using algebra. HiO4. I know hydrogen is going to be +1 because these are nonmetals. Oxygen, each oxygen is -2. So again, when we say these are the oxidation number, it's for each one. So now I can use algebra to figure out the iodine. So 0 is equal to 1 plus, I'm going to use X for iodine, plus 4 times -2. And we get X, or iodine, is equal to +7. Okay. For NH3, here each hydrogen is going to be +1. And again, nitrogen, we can look at our periodic table here. It's usually a -3 charge. And again, those charges cancel out, and we get the correct answer. Let's look at this one. What if we have an ion, SiO4 -1? So each oxygen is going to be -2. So for SiO4 -1, get rid of it. We know oxygen is -2, so we can use algebra to figure out silicon. So the overall charge here is -1. So when I set up my equation, it's going to be -1 equal to silicon plus 4 of those oxygens. Each oxygen is -2. So if I do the math, silicon -8 is equal to -1. Silicon has got to be a +7 here. Alright, I want you to try to figure out the rest using the rules. Feel free to refer to the rules. Again, for neutral chemicals, the overall charge should equal 0. For any ions, it'll equal whatever the ion is. Alright, that's it for oxidation numbers. Practice, practice, practice. We'll be doing this a lot this